All right. So, hi everyone. My name is Viraj, and welcome to the post-contest discussion for Starters 174 in Codechef. We'll be discussing the 4 problems in Diff 2 today, A, B, C, D. How many of you were able to solve till C, let's say, or D, let's say? How do you feel the contest has been? Okay. All right. 1 Diff 2. Okay. Okay. Fine. So we'll try to take I think a little more than what is there. So I'll try to keep it very, very interactive. Okay, you can open your mic, ask questions to me, and we'll try to cover like these 4 problems very nicely so that there is no doubts, and hope that helps. There is no like advanced data structure that is being used till the 4th problem. So it's all logics. If you're able to grab that, I think that would be fine. Okay, should we start? So before we start, actually, for all those people who will watch this later, uh, let's quickly run into our newest CP sheet that has been launched recently, CP31 sheet version 2. Everyone can find this link as TLEeliminators.com CP sheet. And for all those of you who are not aware of this sheet, we have launched this sheet previously in version 1. This compasses 31 problems to be specific, from ratings all up to 1900, right from 800, all 31 unique problems where there are usable concepts that we use. You can find this problem with all the problem links, the note section for you to create, the revisit part, the discussion section, marking off as a status, and connecting in code forces also, along with a very nice leaderboard that gets connected over here. By the way, added to this part, we are also covering video solutions every week for this particular problem set of 31 problems, right from 800 onwards. So that is going to be available on the sheet itself and has a direct link to YouTube. So all those people who are watching this, you can start solving this sheet along with us. And if you start facing any problems, you will start finding video solutions also. The best content available, by the way, on TLE's channel. All right. I hope this works out. Let us begin. All right, so this is the first problem. How many of you solved the first problem? I think everybody solved the first problem. Yes. Okay, cool. So let us discuss this quickly. Deletion and difference. What is given over here? Choose 2 indices I and j such that, so given an array of length n, you can choose I and j indices such that ai is equal to aj. And then you delete both ai, aj from this array, and then you append ai minus aj mod value to a. Now the length of the array, of course, reduces by 1, and all the elements reorder themselves accordingly. You have to find the minimum possible length of A after you have performed this operations as many number of times you could have done, or several times possibly, whichever you feel is nice. Okay, clear? All right, so let us look at a quick generalization of this problem. You have an array A to begin with. You have the numbers. So array A, A1, you have A2, A3, so on till AN. You pick up any 2 numbers and their difference is inserted back in the array. So if I, let's say, pick up A2, let's say I pick up, let's say, A3. So I pick up A2 and A3, conditional that they are equal. On condition that they are equal, I pick them up and basically I insert the difference A2 minus A3 back in the array. A2 minus A3 back in the array. I keep on doing this, the size reduces. Let's find the final size. All right, so I hope the problem is clear. If you look at one of the test cases, I think they have given very small cases. I'll give you something big. Let's say the array looks like 4, 4, 0, 1, 2, 2, 2, something like this. So what can I do, guys, in this? I can pick up this 4 and this 4, and I can basically trim them down to a 0. Is that right? 4 minus 4 is 0. They are equal numbers. Similarly, I can pick up these 2, 2 and 2, trim them down, insert their 0 back. So now the array looks like this, 0, 0, 1, 0, 2, something like this. Now I can pick up two zeros, insert their 0 back, 1, 0, something. Then I'll pick up these two zeros, which are equal, by the way. And now it looks like 1, 0, 2. So what's the lowest size I could have achieved? 3. And that's the answer. No problem. Yes, guys, clear? Now let's try to first of all understand that if I have to begin this problem, I need to first of all know a very important factor, that is because the elements are equal. Observation number 1, because the elements are equal, it would be very nice if I already know the initial size of or initial frequency of every element. Is that right? If I have frequency of every element, frequency of each and every element, then it's going to be very, very easy to me to deduce that from that element, how many pairs I can actually form. Is that right? Let's say you know that 5 element comes 3 times. What does that tell you? How many pairs do you think you can create? You can create 1 pair, correct? And how do you actually create that 1 pair? Or how do you find that 1 pair? You'll say, okay, 3 by 2 floor value is equal to 1. So 2 pairs, if I do a 3 by 2 floor or simply 3 by 2 in integer division, I get that value of how many pairs does that make sense. Is that right? Is that correct? Yes. And leftover number of this particular frequency can be simply written as 3 mod 2. This is the leftover part. So in this case, if let's say 5 was given 3 times, you could have made 1 pair and 1 5 would have been left back. This is what you get. I can do this for every number. Yes. Observation number 1, clear? There's no query in that. Now the next thing is, what happens actually when you pick a pair? What do you actually create? It's very obvious. Because you always make sure that you have picked up 2 numbers which are equal, you basically create a 0 for yourself. Is that right? Correct? So if you currently think that you have picked up some number of pairs over here, X number of pairs over here, then you have basically inserted X zeros back in the array. Is that right? Yes. I hope this is clear. Okay. Now, what happens further? Let's say for every element, you went ahead and you said, okay, the by 2 value is how many more zeros that I created. Fine. At the very end, what is going to happen is you will have these X number of zeros. Let's say X was 6. So after the initial zeros that were there in the array and the new zeros you created for yourself, let's say there are 6 zeros. Now tell me guys, can I argue over here? Can I put an argument that X zeros can be converted to 1 0 only? Always. Can I argue this? Yes. Everyone? So I can say that if I have these zeros, what I can do is something like this. Let's pick up these 2 zeros. I get a 0. Now with this 0, pick up this 0. I get 1 more 0. 1 more 0, pick this up. 0, pick this up. 0, pick this up. So on, so on, so on, so on. This whole array will reduce or boil down to a single 0. Is that right? Clear? So now I have a very simple and greedy based strategy. Let us start with every number which is not 0 right now. So any number, any element that is not equal to 0, I'll make sure that I first extract the pairs. So whatever is the frequency by 2, I add these many number of zeros, add zeros, and that frequency mod 2 gets left behind. When I come out of this whole idea, this whole structure, when I've explored every element that is not 0, now just make sure that all the zeros that you have, basically, all these zeros can be made 1 if their count is greater than 0. If their initial frequency, like this final frequency that you have achieved, is greater than 0, then they can be made to 1. So this one, if it's there, if it's not there, then it's fine. But if it's there, plus all of the left behind values gives you the minimum array length. Is this clear, guys? No issues? Any problem in this? Okay, great. So should we move on to the coding part? Yes. Other people in the chat who all are there, I think. Yeah, let's move on to the coding part. Okay. So as I said, I'll create, let's say, a t size, t test case, and an n variable, a vector, a map. Let's input and create a map out of it. Let's go inside the map. Remember, I have done a small thing over here. I'm not sure how many of you are aware. I've done auto and then ampersand I. That means I'm referencing directly inside the map. Now, if it.first is 0, that means I'm skipping the 0th element. So I don't want that. I'll continue. But if it's not, then I need I.second, that is the frequency of that element, by to number of zeros, get added in MP of 0. And this frequency goes down to I.second dot modulo 2. Now, when I've done this, the map has modified, remember, because I was ampersanding I. So I know I was taking a reference to the direct values in the map, not a copy. If I would have written something like this would have not worked. So this is very important. I hope you guys know this difference. Yes, there's no issue in this difference. Yes. Again, implementation can be done in different methods also. So that's not a big deal. I hope this part is clear. Now I go back. What's the answer? Answer is that the smallest length of array that I'm trying to create with me. So I'll say, okay, starts with 0. I'll go back in the map. Now, if the number that I'm talking about is 0 and its frequency is greater than 0, then I just need one addition to my length, because I know contribution of all zeros will just boil down to 1 0. Else, if it's not a 0, then whatever is left over from I.second mod when it happened gets added. So if it's a 0, it's a 0. If it's a 1, it's a 1. Either this value is 0 or 1 only, because I've done a by 2 over here. Now I print the smallest length outside. This works for all cases over here, and it's of course gets you accepted on the platform. Clear, guys? What is the time complexity? I have taken a map, by the way. So you could have taken some sort of an unordered map also in this case. That would not have been a big deal. But just for this part, I think constraints were clearly available for me. So this is like an n order over here. I can say this is like a log n order extra coming from a simple map. Then this iteration on map can be like n order, and then all this extraction is log n again. Similarly, this iteration can be roughly n, and then this all this I.second, I.first extraction can be log n again. So I can say that overall time complexity on the upper bound turns out to be O of n log n, which is fine because I have n as 2 into 10 raised to 5 order. So if I plug 2 into 10 raised to 5 order log of something, so this roughly gives me something like a 10 parsecs order, which is going to work. Space complexity is O of n only, which is 2 into 10 raised to 5 order only. So that is absolutely fine. Okay, great. I hope the problem is clear, guys. You already solved this, so no worries. We covered this quickly in 10 minutes. Yes? No doubts in this? Should we move on? Okay, MM is saying yes. Vinita is saying yes. Great. Let's move on. So I think this was a tough problem. I mean, not exactly sure, but any ideas that you have, you want to pitch in? Find maximal and trying to make leftmost right. Okay, so I think that is not right. So how many? Okay, let's see the problem. There are n mystic slimes arranged in a line, and the power of the ith slime is ai. you need to perform the following operation until only one slime remains. Choose two elements, two adjacent indices I and j. They should be adjacent, and I minus j mod should be equal to 1. So that is the physical meaning of adjacent. Let the ith line eat the jth line. After this operation, the power of ith line becomes max of 0, ai minus aj. That's the difference. So basically, if ai minus aj doesn't agree or goes negative, you replace that with 0. That's why the max value over here. That means it is not necessary that ai is greater than equal to aj. Even the smaller slime can eat the bigger slime. Note that after each operation, slimes decrease by 1. They all reindex themselves. Relative order between the uneaten slimes remains unchanged. Find the maximum possible power of the last remaining slime. Right. So what do they say in the problem? You start off with an array. We'll call this n size, array A, n1, sorry, a1, a2, a3, a4, so on till an. You can pick up adjacent elements. So let's say I pick up these two elements. And what happens is, it doesn't matter who I pick up as I and who I pick up as j. Is that right? Like I can say this is my ai element and this is my aj element. Or I have an option that this is the aj element and this is the ai element. It doesn't matter whatever I select. Whatever I select, I have to follow the equation that if, let's say, I have to follow the equation that ai will be replaced with max of 0, ai minus aj. And then aj will be removed. So now they're saying by using this operation, you can keep on performing and keep on doing this till, of course, the size of this array reaches 1. Because when ai is only there and aj gets removed, of course, the size decreases. So it will happen that sometime or the other, the size reaches 1. And after that, you cannot do anything because there is no two elements to take a neighbor from. When you do that, you will, of course, be left with some last element, let's say, something like a of whatever that value is. You will be left with this last element. I want this last to be the largest possible left element in the array. Clear, guys? Okay. Okay. Now, let's try to discuss the idea in this. Now, first of all, guys, like I think everybody is pitching a max value sort of a thing. All right. Everybody is doing that. Before we actually do that, let's actually discuss one thing that, tell me, guys, if I talk about any general element, let's say the array is A1, A2, A3, A4, A5, A6. Let's have 6 elements. Now, let's say that I eventually want, okay, I eventually want that this A4 guy is where I will pinpoint my finger. And this A4 guy is something I want to make sure remains at the end. What can I do? If I want this A4 guy to remain at the end, that means I basically want that this portion turns out to be 0. And this portion also turns out to be 0. So if the elements could have been 0, A4, 0, then at the very end, you would have actually gotten A4. How? Just do like simply A4 minus 0. Then your array would have turned to 0 and A4. Then do this A4 minus 0, like taken I and j differently. And then that would also result in A4 minus 0, that is A4. So can we guarantee that you would be left with A4 only? Yes. Is that true? Now, is this guaranteed for A4 only? Do you think you can do this for other elements also? Let's see once more. So let's say that I argued that I would do this for A4. How about I would have tried to do this for A3? That would have been the same thing, that I would have tried to make over here 0, over here 0, and then do that. Correct? Is that right? Does this make sense? I could have also done this, by the way, for A5. Maybe. Now, when I say actually, by the way, when I say I want to make this 0, how do I actually do that? Let's discuss this once more. Let's say A4 is some value, and I'm arguing you want to make the left side as 0. How do you do this? What you can do very simply is you can, exactly, that's right, MM. So can I say that, let's say I pick up these two elements, A1 and A2. Now, if A1 is lesser than A2, then what I can do is I can make, or less than equal to, for example, I can make A2 as I and A1 element as J. Sorry, the other way around. I can make A1 as I and the A2 element as J. How does this help me? Because now if I do, I will have to replace A1 with A1 minus A2 comma 0 max. And because A1 is lesser than A2, A1 minus A2 will be less than equal to 0. This number is going to be less than equal to 0. Is that right? Meaning effectively, you will get A1 as 0. Is that correct? Which means that there is a very smart idea I can follow. I can always select lower of the two numbers I and J and make a 0. Is that right? Is this clear? Yes, everyone? So I can keep on doing this. Like if I made a 0 out of this, then I can take this 0 and this A3 again and make one more 0 overall. So that means the right portion would have ended up with a 0. Same thing over here. A5, A6 can be taken. Same strategy followed, created a 0 over here. So I can very smartly always create a 0 next to A4 and on the right of A4 also. Okay, I think this makes sense. But let's go back. When I asked you the next question, tell me guys, besides A4, how many other elements do you think you can actually do the same thing for? You can do this for A3? Yes. Why to be specific A3? Can I not do this for A5? A3, A5. Okay. So Nazir, why are you saying A5? A1 and A6 also? Like if the array is A1, A2, A3, A4, A5, A6, then if I let's say pick up A5, then this left portion can be made 0. That is right. I can make this portion 0, but over here there is only one element, right? Exactly, MM. That's right. So only like in this I can very well see that A5 is not exactly possible to have a right segment also as 0. In the right segment, there will be A6 left. Is that correct? Exactly. Yes, we need this thing, right? We need at least two elements. Exactly. So because over here we had only one element, we need more than one element to actually club up a 0 by the strategy, the clever greedy strategy that we just discussed. Take two elements, but there should be two elements, right? At least. Same thing. So that means right now I can write it like this. If I put a tick over here, only the elements A3 and A4 can follow this strategy that their left and right halves can be made 0. Is that right? For A5, A6, A2 and A1, I cannot do that. Is this clear, guys? Is this clear? So right off the bat, we have made our cases very small. Haven't we made our cases to now look simple and say that case can be, if let's say I belongs to, say if this are indexes 0, 1, 2, 3, 4, 5, something like this. If let's say, so, oh, okay. So Nazir, I'm saying that we cannot make the left half. There is no left half in that. I'm just saying that part. As you, again, that idea wise is right. So, okay, let's take that also into consideration once more. I was just talking about a left and right half, but there is no left and right half to A1 and A6. So I just said that, but I think we can consider it directly also. Let's talk about A1, for example. Tell me for A1, you can create the right half as 0. Okay. You can do that. You can create the right half as 0 right now. And the left half is also 0. Is that right? Left half is also 0 because there is no left half indirectly. So if we talk about logic sense, then yes, I can say that A1 also has a left half, which is nothing. So it's 0. And A1 also has a right half, which is can be made 0. Is that correct? Yes, guys, can be made 0. Okay. Okay. Now, what about A6? Same idea. A6 right half can be made 0 and left half can be also made 0. I hope this is clear. Yes, guys. Okay. Okay. Now, tell me, when I talk about, like, I can now write a case over here simply that I know that if I pick up some element, some index I, and that index I is not equal to 1, or I is not equal to n minus 2. Does this make sense? If I is not equal to 1 and I is not equal to n minus 2, then basically there can be a left half and there can be a right half. Is that right? There can be a left half, there can be a right half. Correct? Yes? No, I'm not saying the answer can be AI. We'll tackle one more case in this. So up till here, the part is clear. Yes, guys. If I is not equal to 1 or I is not equal to n minus 2, then there is a right and there is a left half. What is that right and left half? We have to calculate. Why am I breaking one more case over here? Is because very simple idea. Tell me, guys, for A3 element, right now, for A1 also, everywhere you saw that left and right half were 0. But let's take one case like this. Let's say the elements looked simply like this. A1 and let's say A2. Now in this case, this is I equals to 0. It of course has a left half as 0, but the right half is not 0. The right half is now A2. Is that right? Correct? So I can say that I want to make a left half and right half. It is dependent. It is dependent on the element sizes that I have. So basic idea, the basic very crux idea in this thing, of course, stands is that if I'm talking about the left half, then left me, either I have more than one element or 0 elements. Then I can say that the left half is 0. Else, the left half is A of I minus 1. Is that right? Or just the previous element, basically? Yes, guys. If the left half, let's say you're standing at this location. So you have more than one element in the left half. So automatically this can be made 0. Or there are no elements. That means you're standing over here. So up to left kuch hai nahi. There is no left element. So if there is no left element, there is no left half, then automatically that is also 0. So both these cases, left half becomes 0. Else, that only means you are standing at some case like this. In this case, the left half is actually the previous number, that is A1. Clear, guys? Correct? Okay. So I can remove like this. That doesn't make sense. So by this overall idea, I have basically found left and right. Is that correct? I have found a left and I found a right. Okay. I hope this is clear. I found a left right now. I can do the same thing and I can find the right. I can say that if I want to find the right half, either on the right of AI, I have more than one element or 0 element. As in no element, you can say no element. Then I know right half is 0. Else, right half is A of I plus 1. Is this also right? Correct? Clear? Now, I have, by this whole idea, I can run a for loop and I can make sure that I create a left half and a right half for every AI. So that for every AI, I get a left half, I get a right half. Now, if I'm making sure that the number AI is the power number, this number stands at the very end of the whole argument. This is the power that is left behind. That means that I want AI minus left plus right to be actually the final power left. Is that correct? Does this make sense? Yes. I can say that standing at some AI element, I will calculate the right half, I will calculate the left half. Let's say it is 0, this is 0, or this is 0, this is some greater than 0 number, or this is 0, this is some greater 0 number, or both are greater than 0 number. Any of these cases that happen, it doesn't matter, because I want that this location stands at the very end. That means I can make my finger right over here, I can make my pointer right over here, and from this number I can decrease this also by first of all keeping this as I, this as j something, and next time this as I and this as j. So AI minus this, or basically the sum of these two values, whatever these two values come up, all four cases get handled in a single equation. And this becomes the maximal power you could have gained had you fixed yourself on an AI number. I hope this is clear with everyone. Is this making sense? Clear? Nazir, Vineet, is this clear? Now, you guys mentioned the idea, like anybody who's watching this video, I think you must have gotten a solution where you could have said that, sir, what the thing that we are doing right now, we just did this only for max element. Is that correct? You must have done something like this. I'm like some logic like this only, but you did this only for the maximum element in the array. You did not do this for everyone. Is that correct? That is not right. Why? Why do you think that is not right? Any ideas? Like, I know you must have not gotten a right summation on that. Did you get a right summation? I think so. No. Yes. This is not going to work. If you take AI value always as the maximum number in the array, then that is not ideally right. 4, 5, 3. Okay. 4, 5, 3 should give you, okay. Otherwise, yeah. Correct. A lot of cases, yes. That is a good case. We can take it. So anybody who's watching this now, 4, 5, 3. Now let's say that I make sure that I talk about 5. Now 5 being the largest element, on the left there is 4, on the right there is 3. So left half is 4, right half is 3. So 5 minus 4 minus 3 will effectively give you, you can say this is -2, but you don't want negative value, so this will effectively go down to 0. So you would report your answer as 0. But the better idea, the better approach would have been from 5, 4, 3. If you would have kept your finger at this number 4, then you could have made your whole right half as 0. Why 0? Because the right half has more than one element. And now your answer would have been simply 4 minus 0. There was no left half. So 4 minus 0, which is basically 4 only. It's a better answer. Yes, good example, Nazir. So is this clear with everyone? Why is the max strategy not going to work? That means I need to make sure that I do this for every element. I need to go to every position, and for every position, I need to find a left half, a right half, by any condition format that I can do. Use any sort of your if else checks, however you want. The crude idea should remain same. Find a left half, find a right half. Possible left half can be 0 or just the previous element. Possible right half can be also 0 or just the right element. And from that, finally, subtract the sum of left and right half from this AI number. That is the last remaining final power. Out of all such final powers, take the maximum possible. Clear, guys? Okay. Okay. Clear. Let's move on. Next question. Let's see the code first. Now, this is the code. What I'll do is I'll take the array input, I'll take the test case input, I'll take the n input, and I'll take the, yeah, Kanish, please do ask me. Can you, like, would you want to open your mic? Does anybody else has any doubt? I think Kanishk is typing something, or yeah. Yeah, what are you saying? Oh, you typed by mistake. So there's no doubt? Clear? Okay. Great. So I think this is a very simple question. We just had to understand that, okay, we can make the any random element as the final power. And I think this intuition everybody got. It's just that this max might could have been a problem. So anybody who's watching this video right now of YouTube, make sure that you have this idea very clear. Greedy max is not going to work. You need to consider this for every element. Let's go back in the code. I said, okay, let's take a t, then n, then vector input. Very, very simple. Now I have an answer variable. This is starting with 0, which is very obvious because I know that the answer, least answer possible is 0. Is that right? Can I make an answer less than 0? Of course, no. Because always I'm making sure that I only keep greater than equal to 0 values in the array by the operations that I do. So 0 से ज़्यादा सम ही होगा, 0 से ज़्यादा ही आंसर होगा, 0 से कम तो नहीं होगा. I cannot go less than 0. Okay. Now I'll go to every element and I'll try to figure out a left and a right half. Now how do I do that? Now what is left half? If I is not equal to 1, if I is not equal to 1, which means I is 0, 2, 3, 4, or 2, 3, or the last. In this case, let's say if it was 6 size. That means left half is going to be 0. Yes. If I is not 1, then left half is 0. And if I is actually 1, then left half is the first element, that is a of 0. This one. Same thing. If I is not n minus 2, this is this index. If it's not n minus 2, then okay, you have the right half as 0. Else it is the last element. And then answer can be simply answer of ai minus left minus right, or basically ai minus left plus right overall bracket, whatever you can write this, all up to you. And that turns out to be the answer for that particular index. Now I can print this answer at the end. What is the time complexity? Some complexity from looping, some complexity again over here from with looping, and then everything inside this is pretty much constant. So now I have a O of n order solution, which is O of 2 into, I think the array size was, oh, very small, 2 into 50 only. And what about space? Space is also O of 50. Great. I think fun problem. Yes, guys. How many of you this is clear? Let's quickly get a yes and move on. Great. Thank you so much. Let's move on. Next problem. GCD add size. You are given a sequence of n size. Your task is to choose a non-empty subsequence B of A to maximize FB. Here, FB is defined as this value. That is, you can say GCD of B1, B2, so on till like the mod of B, which means that what is the size of the non-empty sequence B that you took, and the GCD of B1, so on till B of mod B, that means GCD of all the numbers in that subsequence that you took. If we figure out this FB value, we want to maximize that. Okay, let's quickly generalize this. I hope everybody understands this subsequence. Yes, there's no problem understanding a subsequence. You begin off by saying there is an array, n, size A, A1. Pick up any numbers from this array, which might or might not be continuous. That is the definition of subsequence. Subsequence means let's take any number. So maybe I pick up A2, maybe I pick up A4 and A5, for example. Now, if I do this, I'll say this creates another subsequence B, which has A2, A4, and A5. Now I find that what is the size of this B, which is in this case 3. I find what is the GCD of this B array, that is basically GCD of, you can say A2, A4, and A5. I add this up, and this turns out to be some value, let's say V. I want that all such possible subsequences that you make, everything that you do effectively, this V turns out to be the largest V. This is what I want. Is this clear, guys? Any problem? Question is clear? So they have taken a very strong casing over here. Let's say 6, 1, 1, 3, 3, 3, 3 something. You can take these 4, 3, and this 6. So 6 and these all 3 together give you a GCD of 3. And then the size of the subsequence that you made was 5. So 3 plus 5 turns out to be 8. That's the answer. Okay. I hope the question is clear. Let us move on. Any problem? Yes. Questions are very simple. Great. Let's move on. Now, there is a very, very strong point of start in this problem, and I'll give you my intuition behind this. Can you see that AI is very large? AI is 10 power 12 order. Is that correct? AI is 12.10 order. So do you think you can find, like, because you're talking about GCD, right? We are talking about GCD. So that basically means you would need the factors to find GCD. To find GCD, you would require the factors, right? But then 10 power 12 is a very large number. So is it possible for you to pre-compute the factors till 10 power 12 order? Not possible, right? It's not possible. That means, first of all, the question, when I saw the constraints, is a very strong intuition that, okay, I know that I cannot create factors of every number pre-hand. That means there has to be some smaller limit where I need to work. Is this clear? Is this intuition making sense? I need some smaller limit on which I will work. Because if I have a larger limit as 10 power 12, when I blindly take 10 power 12, that is not going to work. This is a very large limit. Is this clear? Thumbs up? Yes? Okay. Now I said, okay, let's try to generalize my answer. Let's just forget that what can be the multiples and everything. Let's just try to generalize some answer. Let's just say that when I figured out this, let's say I took some elements, okay? And when I took those elements and some random elements that I took, and their GCD turned out to be G. Let's say the GCD turned out to be G. Then what is the answer exactly? What is the value of FB? Can you tell me? It's of course G plus what? Very important question over here. If I took some numbers and their GCD turned out to be G, then if I have to create an FB, or to be specific, the largest FB possible, then what should I do exactly? That's very right. Nazira said this. Shouldn't I make the G value over here, that is as it is, but if I have to make sure that this G value doesn't hamper, this doesn't change, that means the elements that I take should actually be the multiples of G. Is that right? Let's say G is 3. So all the 3s that are there in the array, all the 6s that are there in the array, all the 9s that are there in the array, all the 12s that are there in the array, all the 15s that are there in the array, all these numbers can be taken, yes, in the subsequence. They will give you a GCD 3, yes or no? Is that correct or no? Yes? I hope this is clear. Okay, great. Now, tell me, guys, if I already, like, I have a GCD G value, and I know that if for that G value, if I want to create the maximum FB, I want that G value and all the numbers that look like the multiples of G to be kept over here. My next question rises is, then this G value that I'm talking about needs a range. ये तो मैंने general निकाल लिया. I put a general G. But then this G has to belong from somewhere to somewhere, right? मैं हर कोई जीसीडी का हर किसी जी वैल्यू का तो नहीं निकाल पाऊंगा ना. आई कैन नॉट फिगर आउट जीसीडी फॉर एवरी जी वैल्यू. I cannot figure out FB for every G value, right? There has to be some range on this. Is that correct? There has to be some range. Okay. Now, first of all, tell me, guys, what do you think is the largest answer possible? What is the largest answer possible to this question? Can you take, like, because you want the largest stuff, can you be very greedy and you can select all max elements in the array? If I select all max elements in the array, then the GCD will become equal to mx, and FB value will become this G value, that is basically mx, plus whatever is the frequency of mx. If I would have taken a subsequence that only has this maximum elements. Is that correct? Is this a good starting point? Yes. Okay. Now so I basically figured out two things. I figured out this thing and I figured out this thing. From there, now I ask this question back to me. What is this range of G? See over here. What is the largest G you could have created? It is mx. Yes, largest G that you could have created is mx. Everybody. Correct? So this means that if I now ask you that G has a range, us range ka largest upper bound to mujhe mil gaya, that is mx. Is that correct? I got the largest upper bound, mx. Any problem in this, guys? Largest G that I would want to create is mx. I just want to figure out what's the lowest G I can go. Is that correct? I just need to figure out that lowest G. And if that lowest G is within the level of what I would, or what I can basically figure out that, okay, if this is within the range of my calculations, then maybe my solution is clear. My question is solved. Does everyone agree to this? Vinith is saying yes. Okay. Nazir, yes. Yes. Okay. Clear. So I'll say that let me try to smartly figure out this lower bound. Now I'll give you a very small strategy over here. Now tell me, guys, let's say you had, yeah, correct. That's Nazir, that's correct. Let's say you had mx right now, which you took as G. Maybe you did not take mx as G. Let's say you took the second max as G. You started decreasing yourself. You started saying that, let's say not even take second max. Let's say I took mx minus 1 to be specific. Let's say I took mx minus 1 as G. तब कुछ आंसर आता, right? This would have been giving me some answer. Let's say this gave me answer 1. Let's say this gave me answer 2. Then I would have taken mx minus 2. Answer 3. Go on, go on, go on, go on, go on. Now tell me, when I reach mx minus n, what is the largest answer you can get? Tell me. When you read mx minus n, you basically say that the G value is mx minus n. So you can say that your FB value would have been mx minus n. Is that right? This is definitely there, this much. Is that correct? Yes, guys. Now added to that, you would have written the frequency of all the multiples of mx minus n. You would have added that. Yes, all the frequency. Is this right, guys? This is what you have done. What should you have done? Everyone, yes in the chat. Now tell me, guys, if I look at this particular value, what is this largest value? What is the largest value this can be? You're basically taking the summation of all the frequencies in an array. Now this number cannot be greater than n, right? This is the summation of the frequency of the array. So this is basically the maximum size of array you can take. This cannot be bigger than n. Can this be bigger than n? Can this be bigger than n? No. That means if let's say you find a best case, and in best case, this actually turns out to be right equal to n, then also your answer turns out to be mx. Why? Because mx plus n, minus n plus n, and n would have been getting cancelled. Is that right? So your answer would have become mx. And look back, see over here. Already your answer was mx plus frequency of mx, which was already larger than mx, larger than equal to mx. Now, after this, if let's say after this you consider a GCD of mx minus n minus 1, let's say you would have considered this, then what would have happened? Your GCD would have been mx minus n minus 1. And let's say plus maximum frequency would have been n only. Then this n and this n get cancelled and you go mx minus 1 as your answer. So after this point, as in after this point, your answers are always decreasing. Always decreasing. Yes, yes or no, guys? Is this clearly observable? After mx minus n, if you consider more values lesser than this, then even if every array, every element of the array is covered, even then your answer is lower than what you could have created right now, that is mx. So because like answer right now is mx minus 1. If you'd have taken mx minus n minus 2 plus n, then answer would have been mx minus 2. And this is even lower, and so forth and so on. You would have gone even lower in your answers. So that is something that is not what you want. I hope this part is clear. This is the main idea in this problem. Okay. That means that now I have also figured out a lower bound. I can say that I only want GCD value of G to run from mx minus n to mx. Is this clear? Now, this range is not going to be very, very big. Is that correct? Because even if the array elements, like if you talk about the array elements are roughly in 10 power 12 order. And then the size n is roughly in 10 power 5 order only. So if you calculate mx value, and let's say that turns out to be 10 power 12, then mx minus n will turn out to be something in still 10 power 12 order only, 12 power 10 minus 10 power 5, something like this, which is like just 10 power 5 difference, right? The gap is only 10 power 5. So you would only calculate G, keeping the G value for only roughly 10 power 5 numbers. Is that right? So if you run a loop, if you run a for loop, which is controlling G, then this is going to run in O of 10 power 5 order. Is that correct? Yes, guys. Any problem in this? No problem? I hope this is no issue. Now, inside this for loop, what do you want? If you have a G value, you want that all the multiples of G get counted. So you want G, G into 2, G into 3, G into 4, G into 5, and so forth, until you reach some multiple of G, which is lesser than equal to 10 power 12 only. उससे बड़ा तो नहीं चाहिए. We don't want anything beyond that. Yes. Yes. So now tell me, guys, how much complexity do you think this is going to take? If I run a for loop, which runs from G value, let's say, and then you can say G plus equal to G, something like this. This is a sort of a sieve algorithm. Is that right? Sort of a sieve logic, which means this is going to run roughly in a log base 2 order. Log base 2 of something like a G order. Is that right? Is this good to write this over here? Does that make sense? Vineet is saying yes. Nazir, is this right? Yeah, to be specific, like, yeah, so you can say something like this. Log base 2, I said, because, yeah, I think I took C directly. So for that part, it's like because you're jumping G parts, so you can say log base G, and then whatever is the gap that you're talking about, roughly. Or to be very specific, I can, like, in a max case, take 1E12 also. That's right. So a 10 power 12 order. Clear? But this anyways tells me that I'm going to remain in a decent order only. Okay. Is this clear, guys, everyone? I hope this part is clear. Other people, MN, MM, is this clear for you? Pavan, clear? Okay. So this is the pseudo structure. I'll once more repeat the idea for anybody who's watching this. Where do we started off? We said that, okay, I understood the problem clearly. Now I went back and I said that I have some FB value which I want to create. For that FB value, I will take a G, and that G is from somewhere to somewhere. Let's not discuss that right now. Oh, Pavan, why increment in G? Okay, let me okay, Nazir has already answered that. Pavan, does that make sense? Increment in G because we are trying to figure out the multiples of G. Since all the numbers which are multiples of G, if you take that into the B subsequence, they will together give you a GCD of G only. So look over here. Let's say I took a G value equal to 3. That means all the numbers that looks like 3s, 6, 9s, 12s, 15, and so on in the array A, if they are considered for the subsequence B, then they will give you a GCD of 3. Correct, Pavan? So I will make sure that now just G value has become fixed, and I just make sure that I take all the largest multiples that can go. सबकी frequency ले लेता हूं ताकि this value becomes very high. Overall making my FB value very high for a single G value. So this is where my idea starts. I say that for some G value, I am going to make sure that I create the largest FB. How do I make sure? If I make some subsequence has a value of G, that means this part of the equation is constant. And then the other part can be the frequency of summation of the frequencies of all numbers that look like multiples of G. Clear, Pavan? Any problem? Now I said that, okay, we did this generally, but now we need some max, some low, some high of this G. So now we first figured out, which was very intuitive, what's the largest possible answer? Largest possible answer is not more than the maximum element in the array. You can take the maximum element as, like, you can take all maximum elements given in the array in a subsequence B, and that subsequence B will have a GCD equal to MX, and addition to that, the size of that B will be the frequency of that FX value. So your FB value is going to give you MX. The FB value will become MX plus frequency of MX. And this is the largest GCD you could have created, because इससे ज़्यादा तो GCD आप बना ही नहीं सकते हो. इससे ज़्यादा तो you don't have any element greater than MX in that. So how can you create a GCD greater than that value? Correct, Pavan? Yes. So I said the largest upper bound of GCD is MX. Now I said from MX, I can go to MX minus 1, MX minus 2, MX minus 3. I can do this, but till what limit? Now I observe that, okay, if I take a number mx minus n, and for that I figure out the answer is mx minus n plus, best case, all the numbers considered as the frequency. So plus n, which means mx minus n plus n turns out to be the answer, which is mx only. And after this, my answer only decreases. My answer is bound to decrease. It goes from mx to mx minus 1, then mx minus 2, then mx minus 3, then mx minus 4. So if after this point, this boundary, the answer has to decrease, then should I even consider the number after these boundaries? No, I should not. So let's only keep this as the lower bound, this as the higher bound, and only figure out between this. And this is why I say that this is easily doable, because the gap is very limited. So I can just run on this gap, run a multiple sort of a loop. Overall, the time complexity turns out to be easy, and very, very simple. Okay. Is this clear, guys? Okay. Great. I hope this works. Right. So let us discuss the coding part. Let's take a vector A. Now I've taken an unordered map because I have a constant time complexity since I'm not bothered with the orderedness of the elements. Just mx value. So now I'll go in the input, take AI input, figure out the max value, and then increment my frequency also. Now my answer is, of course, n plus 1. Like that's the start right now. Even this could have been 0 also. That's not a worry. N plus 1, why? it's basically like saying that you took all the elements in your B array and their GCD turned out to be 1. That is the lowest that can happen. Yes. Consider all the array and GCD is 1. So n plus 1 is your like starting point. That isse niche to answer nahi hoga. So let's go in the loop. I'll say I. I is basically this G value, you can say. Let me this G value. G starts with maximum of 1 or mx minus n. Mx minus n can be negative also. So if it goes negative, that means I don't need to consider mx minus n. I need to consider my starting point as 1 now. So max of 1 and mx minus n is the starting point for G, lower bound, and the upper bound is just the maximum element, that I don't want to go anything beyond that. Now I have a counter that is basically the frequency of multiples. Okay. And now I have this J loop, basically over here, which basically means the multiple. So I start this off with the multiple G, and then this till this is less than equal to mx, I say multiple plus equal to G. And every time in my frequency map of multiple, whatever that value is saved there, I just keep on adding. Now, if this frequency of multiples that I figured out is greater than 0, then that means, yes, my answer can be made better. I can say that answer turns out to be max of answer, comma, frequency of multiples plus G. So basically, this is the FB value that I have. And then I print the answer outside. So this gets possible solutions for every G value. Is this clear, guys? Any problem in this? Okay. Now, what is the time complexity? I have taken an order map. So this is like an n order. This is pretty much constant. This is the main thing. This is like roughly you can say you have n as 10 power 4 and then 4 into 10 power 5. So this is like roughly like a 10 power 5 order almost, you can say. And then this is like a log base, you can say, of G of something of like 1e12 max. So I can say that my time complexity turns out to be n plus this value. Now, G, of course, is changing, right? G is from 1 to mx, so G will change. So overall, like that, why did I say log was because of this part only? Like if you figure out this time complexity, like log G of 1e12 and G ranges from 1 to the mx value, you will figure out that the gap maximum that you're considering is 10 power 5 only, right? Nazir, is that right? You can consider that gap is 10 power 5 only. So this G value ranges from 1 to 10 power 5 order max in like terms of gap, if you're talking about. So if that happens, then basically you are taking log base 1 of 1e12, then 2 of 1e12 and so on. So that's like a rough estimation that you can write this as log base 2 only. It will turn out to be something like log base 2 maximum. N square root of A. Yeah, this will turn out to be a TLE, Priyansh, because N will be like 10 power 5, then square root of AI would be 10 power 12. So that is TLE. Because like it will just cross the bound, like it crosses, right? It goes in a 4 into 10 power 5 into 10 power 6 order, which is 10 power 11 order. Pavan, okay? I hope this is clear. Yes, guys. So I think this is like a rough estimation to write. You can write this as G only. That's not a problem. The G 1e12 order something. This of course works. Now I have a space complexity, which is simply O of n. Very, very simple. So fun problem, guys. Yes. I hope you like the problem. Should we move on? No advanced data structure was required. Yes, it was very direct. Now let's figure out the last problem. Again, no advanced data structure required. I'll try to keep it very intuitive, discuss a lot of cases, by the way, just that is there. And let's see what happens. Okay. So let's see the problem. You are given an array A containing n elements. A pair LR is called good if mx of 1 to L is equal to, not mx, mex of 1 to L is equal to mex of L plus 1 to R is equal to mex of R plus 1 to N, where mex of an array denotes the minimal non-negative integer which is not present in that array. Your task is to find both minimum and maximum value of this minus this plus this for any good pair L comma R. Now sum of x comma y means basically summation from that x to y. Okay, let us look at the problem. So first of all, we need to clear one term over here that is called mex. What is mex? Mex is the smallest non-negative integer in you can say in a set of numbers greater than or equal to 0. This is called mex. For example, let's say your set of integers are 1, 2, 3. What is the mex of this? 0. For example, 0, 2, 4. What is the mex of this? 1, because 1 doesn't pop in this. This is the smallest non-negative integer. 0, 1, 2. What is the mex? 3. Mex is clear? No issues in this, guys? Okay. Now, what are they saying is they are saying that given some array A from A1, A2, A3, so on till some, let's say there is some elements in this, let's say AL, and let's say there is a range of AR, and then you have, let's say like AN minus 1. So given an array A, you basically have to figure out 3 partitions in this array such that the max from here to here is equal to the max from here to here is equal to the max from here to here. So this is max M1, M2, M3. They are all equal. This is what you have to partition in. ऐसा एक partition करना है हम. And if you are able to do such a partition, what do you want? If you are able to do such a partition, you basically want that you figure out the sum of this first half, sum of the second half, sum of its third half. The equation is S1 minus S2 plus H3. And now, of course, the possibility is that there can be many such partitions, right? Isn't that true? There can be many such partitions. So out of all such possible partitions, you have to tell me that which partition will give me the lowest possible value to this equation and which partition will give me the highest possible value to this equation. And you have to print these two values as an answer. Is this clear, guys? Any problem? Any problem? Okay. I hope this part is clear. Now let us begin solving. Now, first of all, guys, I'll try to pose very simple questions. Let's keep it quickly interactive. I think you will get the problem very, very clearly. There's no advanced data structure, nothing like that. We are using very simple algorithm. Tell me, guys, that let's say I pick up some value AI. Now, if this AI value, okay, let's say that this AI value, now when you do this partition, right? When you do this partition, you are basically trying to create some max, correct? You're trying to create some max value. कोई तो एक max बना रहे हो ना तुम? Some m, yes, you're making some m value as max, right? Now tell me, guys, if this AI value that you randomly pick up has the potential capability to become an m, if this AI value has the capability to become max of some L comma R, then what has to be true for this AI value? Very important question. Any answers? I'll repeat this question again. Should not be in the range. No, nothing like that. I'm asking you a very in basic, simple question, to the root question. Can I say, listen to this very carefully. Can I say that if any element AI has to have the capability to become a max? I'm saying capability. I'm not sure it might become a max. If just that it has the capability to become max, then don't you think that particularly that particular number, it should not be present in the array? No, not that. Like it should, I mean, like it should, yeah, of course. So that is right. If AI number has the capability to become max of this, okay. So Nazir is saying it should not be present in the array. How many of you agree with this? +1. Pawan is saying +1. Other people, +1. Okay. Okay, makes sense. Okay. So I think this seems right. If AI number has to have the capability to become max, then don't you think that that number should not be visible in the array? Yes. Should not be visible. But added to that part, I'll pop the question a little bit more. Let's say that number is visible in the array. If let's say the number is AI is visible in the array, then of course that number is not a max. Can you make that number a max? Of course you cannot make that number an x. But then there's one more condition. There's one more condition added to that. Think very carefully. Now you know that this number cannot be a max because it is visible. Okay, is that right? So if this number cannot be a max and it is visible in the array, then don't you think that this number should have at least 3 frequency? How many of you agree with this part? Imagine, let's say there is a number. Let's say the number is 2. Let's say the number 2 is visible in the array, but it has a frequency only 1. It only comes one time. Now tell me, if it only comes one time, you want 3 partitions to be made. You want this partition, this partition, this partition. You want 3 partitions to be made. Is that correct? So if that number is not a max, it is visible, it is lesser than max. Like let's say the max of the array is actually 4. So if the max of the array is actually 4 and any number less than this, 1, 2, 0, 1, 2, 3, if let's say 2, for example, let's say 2 comes only one time. No, Dhruv, I'm not saying. Okay, I'll modify the question a little bit. I think we got off track. I'm so sorry. I'll modify the question like this. Let's say, listen to this very carefully. Let's say that mx is m value. That means m is not visible. Agreed, Dhruv? If m is not visible, that means 0, 1, 2, 3, 4, 5, so until mx minus 1 should be visible in the array. Yes, should be visible in the array. Now my question is, how many times should they be visible in the array? If they are visible in the overall array, I'm saying, in the overall array, if any of these numbers are visible less than 3 times, then do you think that this m value could be made a max? Or do you think overall an answer is even possible, to be specific? No, right? Because if your max has to become m, then it's very obvious that numbers from 0 to mx minus 1 should have at least 3 frequency. Why 3 frequency? At least 3 frequency because they need to go to 3 different partitions. One frequency of each number has to go in 3 different partitions. Tabhi to max m banega for all these 3 partitions. Is that right, everyone? Now is this answer clear? M has to be in every subarray. No. Dhruv, I am saying that in every, like let's say you're trying to create M max of this subarray, M max of this subarray, M max of this subarray. Okay, Dhruv? Let's say we are trying to create M max. Now, if I want to create M max of this subarray, then that means all the numbers from 0 to mx minus 1 has to be present in this subarray. All the numbers from 0 to mx minus 1 has to be present in this subarray. Yes, mx, sorry, not mx, like max, m is the max. Has to be present in the subarray. And same thing, all the numbers from 0 to m minus 1 have to be present in this array. Is that right? Yes, Dhruv? Now, if let's say you pick up any element from 0 to m minus 1, if it has to be present 3 places, then it needs at least 3 frequency, right? If it doesn't have 3 frequency, then how will m be a max? M cannot be a mix, right? Does that make sense? Everyone agreed? I hope this part is clear. Ordering of the elements. Right, it depends on ordering of the elements, Nazir. We will, like, this is like the very base condition. That is the added condition that you're saying. That's right. That's correct what you have observed. But I'm saying a very base condition that itna to zaruri hai. Then we'll of course see that how do they come up and everything. That is again handled. I'll tell you how. I have just a very base idea in this. Yes, that this has to be true at least. The frequency of all the elements from 0 to mx minus 1 have to be at least 3 in frequency. Then otherwise, if this doesn't work out, then the answer is -1. -1. Is that correct? Is this clear, guys? -1. Why? Because it's written over here. No good pair exists. So print -1. That is the idea. If you are not able to make a max m value, that is only possible if like this condition happens. So you need to check this condition and directly return -1. No doubts in this, guys? Any problem? Okay. Now, if you are not in this idea, if that means you did not return -1, this means you can make your mx m. Yes, you can do that. Okay. So now imagine I am doing a very diagrammatic idea. Imagine this. Now let's say I have the elements A1, A2, A3, A4. Then let's say AN minus 3, AN minus 2, AN minus 1, and AN. Any problem? Now, what will I say? Tell me, guys, tell me. It's a very, like, think this question. If I ask you, what is the least L value you can take? What is the least L value you can take for the segment to start off with? What will be your answer? MX, no, L value. L means index. Like, where is the partition lowest going to start? 1, no. 1 is not right. I need a generalized answer. Can I say that the partition can start from that location before which one time, like before which you can say, before which 0 to mx minus 1, m minus 1 have exactly one frequency, or not exactly, sorry, at least one frequency. Is that right? Yes, everyone. Pawan, yes. M, yes. Dhruv, yes, this is correct. Can you select an L value before this? Can you select your L value before this? No, right? You need to place your finger for L value right at that location. जिससे पहले तुम्हें at least you get one frequency each of 0 to m minus 1 numbers. Else, this portion will not have a max of m. No, Dhruv, I said that every number will have a frequency at least greater than or equal to 3. It should happen. If any number has less than frequency, then the answer is negative. Now, I said it is the possibility that now you will try to check whether I can make it or not. So to do that, I figure out the lowest L. Now I'm starting off with the problem. This is the base condition. This is the base condition. That from there, I can directly figure out the answer is -1. Okay, Dhruv? Now I'll pick off the answer and I'll say, what is the lowest L I can create? What is the largest L I can create? Largest R I can create. Now, the same thing. What is the largest R I can place over here? The largest R can only be at that location, right? Before which 0 to m minus 1 have 0 to m minus 1 have at least one frequency. Is that right? So this is the L where you can start off L's with. This is the possible R's where you can start off R's with. Is that right? This is the possible. I'll repeat again. This is the first place where L can start off with. There is this last place where R can end with. Is this correct? Have I found L and R rightly? Now, the question comes, Nazir, which you asked, and I think Dhruv, this also clears with you. Now, if R is less than L, then don't you think again the answer is -1, -1? It can happen, right? That there is no middle portion left. Like I was trying to find the best L from left. Then I tried to find the best R from right. Now it can happen that I cross this range, right? I cross. This is R, this is L. Now it crosses. Now if that happens, then there is no middle portion for you to consider anymore. Now if there is no middle portion to consider anymore, again the answer becomes -1, -1. Is that correct? This handles, Nazir, your case which you mentioned in the chart, that it also depends on ordering. That's right. Now we have figured out the ordering part also. Clear? So I have now discussed with you two -1 cases. One case is the base case, that at least element from 0 to mx minus 1 should have a frequency less than equal to 3. Sorry, greater than equal to 3. Because in one test case, L was 1, so that means only one element. How does that satisfy m minus 1 condition? Oh, okay. Are you talking about this case? Like, where did you take? Okay, this case, right? Test case 1. First test case, Dhruv. Okay. Now, in first test case, tell me, Dhruv, what is the max that turns out of this array? Max is 0 of this overall array. Yes, Dhruv. If you want to figure out the max of this max turns out to be 0. Visually, no. Visually, I agree. I'm just asking you. Like, I'm trying to ask you. The max is 0 over here, Dhruv. Yes. Now, max is 0. So if you have to create, okay, if you have to create a partition, or basically you have to create 3 partitions, then you should know that numbers from 0 to m minus 1 should be visible in this array at least once. Oh, same thing over here, same thing over here. That you have taken, the first case that you're talking about, usme to max ही 1 hai. So m minus 1 will be -1, right? So that is a separate case we can handle. Is that making sense, Dhruv? Like you have taken a case where max is 1. Sorry, max is 0. So 0 minus 1 will be -1. So that doesn't make sense, right? How to derive max algorithmically? So Dhruv, how do we derive max algorithmically? See, basically you can sort this array and you can figure out from a set what is the first non-negative number that is present. That is your potential M. Clear? Okay. So now when I have this M value, Dhruv, now I'll say, okay, for this M value, I need to say that 0 to m minus 1 numbers pop up in these 3 places. If they have to pop up in these 3 places, they should have at least 3 frequency. So I handle that case. That is the base case. If that hasn't happened, answer is -1, -1. Okay. Now let's go back. Let's see. Now, if it does happen, then I'll try to figure out what's the L location where I can do this. What is the R location where I can do this? Any problem? If R is less than L, which means L crosses R, this is again an issue because now there is no middle portion to take. There is nothing like middle because R crossed L. Any issues, guys? Now, if let's say you have figured out till here, this is L, this is R. Now tell me what is the right now, what is the minimum answer and what is the maximum answer? What is an answer going to look like? An answer looks like sum till L minus middle portion plus sum till R. Is that right? Then max will become -1. Exactly. That's right, Dhruv. Is this clear, guys? This is what we want, right? This is what we want. Okay. Exactly, Pawan. Very good observation. Now tell me, guys, that if I want to find the minimum value, What does that mean? Minimum means that if you enlarge this overall value will go very down. Is that right? Because this value is positive. This value is also greater than equal to 0. This is also greater than equal to 0. Only this minus guy is going to bring your overall value down, right? So if I increase this minus guy's value very largely, then overall value will go very down. Is that correct? Yes. Yes in the chat. Other people, Dhruv. Correct? Who was the other guy? I think there was Vish something. How many people are remaining? Okay, there is only Dhruv, Nazir, Pawan. Okay, fine. Yes. Clear. So I'll say that, okay, if I have to figure out the lowest value right now, then let's go back and see. This is the very start of L. इससे पहले L तो तुम ले ही नहीं सकते. This is the very end of R. इसके बाद R नहीं ले सकते. You cannot take R after this. You cannot take L before this. So don't you think now the next L and R which may happen or might happen will only be somewhere within this range. Is that right? So if that happens, then don't you think the right now best case answer is this portion that we are marking off, this middle portion actually is right now the largest middle portion that we have, because any portion after that is going to be lesser than this only, because now we want to explore other cases where L and R come even closer. Right now they are at the perfect optimum position from where they are starting. Like L is this starting location. I cannot take anything L before this. I cannot take R after this. So this is like the starting point. So that means this segment is actually the largest middle segment I can create. Which means that if I have to figure out the minimum answer, we have already done that part. Just take the sum till here, and take the sum of this. And this minus this plus this is actually the minimum answer that you have. And now we will only work for figuring out a maximum answer. Is this clear, guys? Yes, Nazir, Pawan, Dhruv. I hope this is clear. Okay. So now I'll say that, okay, mx has become this value. Now minimum has become this value, which is basically equal to, if I write quickly mn over here, mn has become equal to sum till capital R, then plus, minus L to R sum plus sum from R to n minus 1. Okay, this is mn. Now mx also can be right now initialized with this value only. And now we can try to find better mx. How do we try to find better mx? What is a better mx? Better mx now will be that now that you have some L and R over here, you try to bring this R and L closer. Is that right? You try to bring this R and L closer. Correct? Is this correct, guys? Now, what is that L and R? How close can you bring them? Like if you bring them like this, like let's say this is the new L and this is the new R. Now this is the new segment. What is that limit where, how much closer can you bring them? Remember, the middle portion also needs to have at least one frequency from 0 to mx minus 1, right? Mx minus 1 or m, whatever, that's mx minus 1. Middle portion also has that. So this L from here can only come closer to a limit where, and this R simultaneously can come only to a limit where you feel that the middle portion still maintains that max equal to m. And how will that maintain that? Which basically means that it still has 0 to m minus 1 values coming at least once. That is still necessary. Is that right? So from here onward, I can implement a two-pointer approach. What I can do is, I can keep my L over here, my R over here. This is my portion behind, this is my portion after, and this is the portion right now where I start off with. Now what I can do is I can keep on first of all decreasing. This is just implementation technique. However you do that is totally up to you. Let's decrease R one by one. Let's decrease R one by one. Okay. Till where can we decrease R by one? Till I'll keep on decreasing R one by one till it reaches a place after which if I decrease R even more, this range will not have at least one frequency from 0 to mx minus 1. Okay. So this is, let's say, the R where I reached, where I stopped, knowing that now this segment still has 0 to m minus 1 numbers at least once. At least once. So I will stop over here. Now, when I made this 2-pointer idea, I'll say whenever I was decreasing R, 1 minus, 1 minus, 1 minus, 1 minus, 1 minus, that means my R segment, sorry, my middle segment, this red segment is going down. Is this going down? And my R segment is going up. Yes, this segment is going closer. This is like this, then this, then this, then this. And similarly, this segment is increasing. This, then this, then this, then this. Is that right? Yes, guys. So does this make sense? So I'll bring my R closer right up to a point where after this I have a problem. Problem क्या है? इसके पीछे अगर ले गया तो अब तो मेरे को at least 1 मिलेगा ही नहीं. At least once मेरे को 0 to m minus 1 मिलेगा ही नहीं. Okay. Now let's say it lands at this value. Now imagine this has become your new R. This is your new R value, which means now you have explored all the possible answers. So your expanded region is from here to here, and this is your region. Now you are of course always noting this and creating mx, like you are always creating some different mx's and you are always maxing because right now everything running is a correct mx value. Is that right? Okay. Now from here onward, I can run a 2-pointer approach. Till where do I want to run my 2-pointer approach? Till that initial R that I had. Now what I can do is, you can imagine, I can place a finger over here. I can place a finger over here. Now what I can do is I can keep on incrementing L. So L comes over here. L comes over here, L comes over here, till where it can go, till let's say a location it reaches, after which again a problem. So let's say it reaches at this location. Let's say it reaches L over here. This is the new L. Now your range has become this much. And your left range has increased and become this much. And your L has been removed from here. Now what you will do is, अगर इस L को और बढ़ाया तो दिक्कत हो जाएगी. तो now what can I do is I can increase this R. Let's increase this R right up to a point where whichever element became 0 at this position, whichever element became 0 from 0 to mx minus 1, that frequency is regained when I moved R. And I will land R till this location. And then I will again make L come forward. Then at a specific location, I'll make it stop, then R more, then again make it stop, then R more, then again make it stop, and so on till R reaches back at that original R value where I started off with. Do you guys understand this 2-pointer approach? This is sort of like saying segment, like there are many questions like this, which we like people solve. If somebody new is watching this, like questions like what is the max ones segment sort of lead code problem, all of this is very, very same sort of a solution on 2-pointer, where what do is you run an R pointer which goes left, 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 and you stop it at some window, and then you try to bring L forward till it's feasible to bring that. So it's the same idea that I'm doing over here. I'm doing a different thing. I'm bringing L forward and I'm stopping it right at the window where it cannot go any forward. And then I'm making R go even forward. Then as soon as the window again becomes good for me, I'll again start bringing L forward. Then again, it stops at some location. I'll make R go even higher so that the window again becomes good for me. Then I'll again explore that window. So I'm creating windows and I'm trying to explore all those windows. Is this clear, guys? Okay, this is implementation difference. You could have done this anyhow. The idea is that overall idea is, if finally you want a brief on this, the overall idea was that जब तुम वो L और R initially कर लो, it will fail in this case. Okay, which case? Okay, 1 3 1 1 1 2, 1, 1, 3, 1, 2. Oh, okay. So this has to be handled a bit differently, right? This has max equal to 0, Nazir. This has max equal to 0. So we need to handle this a little bit differently. Max 0 can be handled differently because when we are talking about max 0, then basically if the overall max of this array is 0 right now, then if that happens, what is the best case that you can do? To create an mn value, what can you do? If you want to create a minimum value, that means you can increase your largest segment. So you can pick up all the elements in the middle. This can be the other segment. This can be the other segment. So this is like the first segment. This is the second segment. And this is the third segment. Now you get an answer. Okay. This is how you get mn. And how do you get mx? How do you get mx? Mx can simply be the most most highest element in the array. Okay, 2, 1. So this is like 2, 3, 1, 5, 3. Mx is equal to, sorry, max. Max is equal to 0. Okay. Max is 0. So according to me, Dhruv, the minimum answer that you can actually do is 2 plus 3 minus 9. What is this? Minus 4. And what is mx? Mx actually can be this segment, this akela number, and then this segment. So this can be 7 minus 5. Sorry, you need the lowest element. Sorry, no? You need the lowest element. You can say this, and then this, then this. So this can be 5 minus 1 plus 5. They didn't bring R back. Clear? Is this clear, Dhruv? Yes? Okay. Because mx equal, like m, if max is equal to 0 of an array, then this whole idea of partitioning right from the generalization fails, right? Because I am saying 0 to m minus 1, and max you are saying is 0. So 0 minus 1 is not possible, right? 0 minus 1 is basically negative 1. That doesn't make sense. So this means obviously I'm talking about max is greater than 0, where I am generalizing all the cases for me. Because if it's 0, then it's a direct case of just figuring out mn like this and mx like this. Clear? So we will say that if max is equal to 0, you will run the idea of the first element being the first partition, first partition. Elements from second to n minus 1 will be your second partition or middle partition, you can say. And then the last element or the nth element will be your third partition. This gives you mn value. And what is mx value? Mx value is equal to whatever is the lowest value in your array, whatever is your minimum value in the array, that before that value, all the left sum, and after that value, all the right sum. On all possibilities, this is the answer. Is this clear? This is for max equals to 0. And if max is not equal to 0, if max is not equal to 0, or basically it's greater than 0, then we need this whole idea of 2 pointers and everything. Okay. Now let us take, I think, Nazir, did you mention some case? Did you mention a case? I think, okay, no, sir. Okay, fine. Okay, so I hope the problem is clear. Yes. Any problem in this? Should we run some test case on this? I think we can take like a standard test case over here. Let's take this one. Okay. 0, 1, 0, 1, 0, 1, 0, 1. All right. Now tell me, guys, what is the max? M is 2. Every element has at least 3 frequency. So my base case will never be true. Every element has at least 3 frequency, right? 0 also has 3 frequency, 1 has also 3 frequency. So it's good to go. Because if I do 3 partitions, everywhere something can go. Yes, guys? Okay. So now what I'll say is I'll figure out the best L where I can keep. What is that best L? This is the cell. Because iske pehle I have at least one frequency of 0 and 1, which is 0, 1, or basically 0 to 2 minus 1, which is equal to 0 to 1. This is my L point. Similarly, this is my R point. Any problem? Now, till now, I calculate Mn. What is Mn value? Mn value is this sum 1 plus this sum, sorry, minus 2 plus this sum back. What does this give you? 0. Go back in your problem. See, is 0 your answer? Yes, 0 was your Mn value. Clear? Now let's go back. Now let's say that first start decreasing R to a limit after which you cannot decrease. So I'll say first R, this is like an original R over here. I'll call this small r. Now this R decreases. It goes this location. Again, calculate the answer. Your answer changes. Your mx answer initially right now was 0. Now your mx answer changes. Mx answer becomes this sum minus this sum. So that becomes 1 plus, sorry, 1 minus 1 plus 2, which is actually equal to 2. So your answer changed, right? Your mx has changed. It went from 0 to 2. Clear? Any issues, guys? The starting L and R questions were this. This was like an original, this is this original R, and this is the original L. Why is this original L? Because iske pehle you got every number 0 and 1 at least once, and after this number, this is like an R, after this you got every number. Okay, clear? Now from this R I started decreasing, so I went on this R. Now I cannot jump over here. Why? Like I can jump at this location. If I jump at this location, then this becomes R, this gets rubbed off. And now what's the segment? Now the segment is this much minus this much. So you do again this calculation. Answer does not change because answer already has gotten 2, so it never increases. But you get the idea, right? For some other test case that we would have taken, answers could have changed. So we are always taking mx equals to max of mx comma the new potential answer that you get by making this 2-pointer approach. That's why at the very end, mx is going to be the best guy. And mn is already found, so no worries about that part. Clear, guys? Any problem? This is a very good problem. It's just that it requires a lot of, I think, diagrammatic idea in this. I hope this is clear. Any issues, guys? You can ask me. Fun? Okay, should we look at the code? Okay, so code is a bit long. Just try to catch up. I'll try to differentiate the cases. You have now in this case, in this question, by the way, there was no test. Like in this question, by the way, I have taken this in a different solve function because I just wrote return in this case. Okay, so it's just implementation difference. I have a main function, take t, call the solve function. Now let's go. Now I take n input. I create the vector. I have the map. I take the input. And I create the frequency map. Now first I'll try to find the max of this array. So I'll say, okay, let's run. Max can be, what can max be? Max can be 0 to less than equal to n. Yes, all these values can be maxes. Correct? So let me run loop from 0 to less than equal to n. Now, if the frequency of I is 0, then this is the max because this is not visible in the array. So as soon as I find this, let's break because now I found my max. Is that right? Yes, guys. This is how you can find a max. And let's say this if check never became true. That means this has a frequency not 0. So that's the case. If this frequency is not 0, then this should at least be 3. Because if this is not a max and it's visible in the array, then if it has to go to 3 different components, then it needs to have at least 3 different frequency. So that it goes in 3 different components. That means if its frequency is lesser than 3, then this is a direct negative 1 case. And I can return over here. Clear? Any problem? Nazir, Pavan, Dhruv? Great. Now I go inside. Let's find that L, let's find that R, and let's have an initial sum. Now I'll create a frequency map again, a frequency vector I've created. I could have created a map also, it doesn't matter. Now, what I'll do is, I'll first of all, in a set, I will insert all values from 0 to max minus 1. Why? Because I want to check the left portion. How do I check that left portion? Let's go. Let's go to the all the numbers from 0 to n. Let's start summing it up and let's start removing that number from the set. As soon as set becomes empty, you know that this location can be treated as the last position up till which everything is found. Every number from 0 to mx minus 1 has been found. So L becomes the index plus 1, I plus 1 location, and you break. Is this right or not, what I've done? Is this right? Yes? Clear? So I have found this L portion. Now let's do the same thing over here. Now set is empty again. Let's insert everything back to the set. Same thing, 0 to less than mx. And let's figure out the R. So let's run a reverse loop, n minus 1 to greater than equal to 0, I minus minus. Let's take the sum gets increased again because this is like the left sum, right sum that I'm getting. So I'm doing this in the same variable. Sum plus equal to, then let's erase from set ai number. As soon as it becomes empty, I know this is a breaking point. R becomes I minus 1 and you break again. So you come out of this for loop also. Now, when come out of this for loop, you have an L with you, you have an R with you, you have a sum with you. Now, what's the next check? Next base check. R should not be less than equal to L, right? Less than L. If R is less than L, that means you have crossed the boundary, which means there is nothing left to keep as a middle portion. If there is nothing left to keep as a middle portion, then this is again a negative one case. This is what we discussed. Clear? Okay, let's go. Now I'll figure out what is the sum from the middle portion. And I want to decrease that sum. Yes, I want to decrease that sum from my overall sum. So I'll say, let's run a loop from L to R and sum minus AI. And then I'm just getting a frequency map of all the middle numbers. This frequency map I'm using for 2-pointer approach later on. That is why I created a frequency map. So I created a frequency map for all the numbers from my original L to original R. Any problem in this, guys? Any problem? Now let's run again a check inside this frequency map. If any number from 0 to mx minus 1 is not visible in this frequency map, that is all the numbers from L to R indexes, then this again is a negative one case. Clear? By middle portion mein, the middle portion that I've right now found, L to R, it should have the numbers, right? It should have numbers from 0 to mx minus 1. M minus 1, max minus 1. Else max will not be created in the middle portion. I need that at least. So their frequency, if it's 0, any number from 0 to mx minus 1 within this range, L to R, which is the frequency map created on the indexes L to R, then again, this is a negative one case. Now, if everything is good to go, now I can find the 2-pointer approach. Now I'll say, what is my minimum answer? Minimum answer is sum. It has not changed. Mx is also sum. And this is my R1 value, which is like my small r that I took over here. Like this is the small r that I had. So I just stored that in R1. Now this is where I handle the max equals to 0 case. This is, I think, Nazir wrote out. This is the global case. If max is 0, then Mn is of course an answer. And I need to find Mx. How do I find Mx? How do I find Mx? Let me find the minimum value from L to R range. So I have an X variable and that X variable gets the minimum value in L to R range. And then Mx becomes all the accumulation of the array minus 2 into that value. Why accumulation of the array is like this sum of the whole array, and why minus 2 into X? Because X will be counted one time in the accumulation. So removing that one time X and then one more time X. Can you show the base L and R? Yes, I can. See, Dhruv. What did I do over here is to find an L, that means I want to find that first location where before that every number from 0 to mx minus 1 comes. Yes, Dhruv? So I will insert every number from 0 to mx minus 1 in my set. And then I'll go run a loop. I will increment my sum and I will erase that number from set, AI number. Now, if set becomes empty, that means is location tak mujhe sare numbers mil gaye. Yes, Dhruv? If set has become empty now, that means till this location, I've gotten everything. Every number at least once from 0 to mx minus 1, max minus 1, sorry. I've gotten that. Correct, Dhruv? So I know that I plus 1, like the index after that is the beginning position of L. Clear? I hope this is clear, right? Like you would have done something like this. You would have gotten 0, then 1, and then you would have stopped because 0 and 1, you got both these numbers, and then the next index would have been become L. Clear, Dhruv? Okay. Now the same thing for R, right? Just from the back. No doubts? Can you move on? Okay, let's go. So now if max is 0, if your max value was 0, then this is how you find for that case. Mn is still that, what it was. Mx is just now, as I told you, we discussed this case, right? What does mx become? Mx becomes what did we discuss over here? Mx becomes left sum minus min plus right sum, something like this. So that is basically equivalent to finding the sum of the whole array, accumulate that, and do a minus 2 into x. Is this clear, guys? This becomes mx, mn and mx printed. Good to go. Okay. Else, let's run a two-pointer approach. So now till r is greater than L, I will try to bring r backward. How will I bring r backward? See this very carefully. Now, if the number that is placed at a of r, it is greater than equal to max, then do you think I want to bother with that number? If a number a of r is greater than equal to max, then I know that number never contributes, right? It is not something that will stop me from iterating. I'm only concerned with the numbers which are less than mx, because those are the numbers I actually want still in my middle portion. If there is some number which is greater than equal to mx, then that number I am not concerned with. Is that right? Correct, guys? Okay. Dhruv, Nazir, yes? Great. So if a number ARR is greater than equal to mx, then I can simply say, okay, this number is something I can still cover. It doesn't matter. It doesn't changes the max of my middle portion. Or if let's say this is not true, then if the number that is there, it is less than equal to mx, but its frequency is greater than 1. If it's greater than 1, that means I can still cover that number because it's greater than 1. It's not less than equal to 1. It's still greater than 1. That means I have more occurrences on the left area. So I can still cover this number. Yes. So I'll try to bring this r. I'll say, okay, if it's greater than 1, then I can still cover it. I will make my sum plus equal to 2 into a of r. Why 2 into a of r, guys? Why 2 into a of r? Because 1a, I had already decremented this number once in this loop. So covering that number once and then one more occurrence of that number, because I now have added that number to my right half. Is that correct? So 2 times of that occurrence. Clear? Any issues, guys? I mean, that is correct, Pavan. I think you can do that. Okay. Is this clear? I think we can do this also. No issues. Okay. Yes. So now you'll say sum increases. And now if the number is less than max, then its frequency decreases and r minus minus. And if this condition is not true, that means neither the number was greater than equal to mx, nor its frequency was greater than 1. That means this is a number whose value is less than mx and this frequency is less than equal to 1. So I need to stop. मैं इसके आगे नहीं जा सकता हूँ. I cannot make my r go any more left. Can I? I cannot do that, right? That is like a stopping point for r. So I will break. Any problem in this, guys? Any problem in this? Hello. Okay. Clear. Now I'll say mx becomes mx equals to mx plus sum, whatever that new sum has come up. Now this 2-pointer idea. L is less than R1. R1 was the original R. While L is less than R1, now let's do something. If A of L is less than mx, decrement its frequency and increment the sum. And then when this has happened, let's run a while loop so that R also jumps more if this number was actually less than mx and I made its frequency 0. If I made its frequency 0, so I need to increment my R until its frequency comes back to 1, because my middle portion should have this number. Is this making sense? Is this sliding window making sense? I think you have seen similar sliding windows, right? Something like a segment sliding window that you can say. You said that you decremented your L value, and if that made your window bad, then until your window becomes again good, you will iterate R forward. Okay? And then this while loop, when you come out of this, you know you're again in a very good window. So if now your window is still not possible to make, you will break. But if it is still possible to make, then you will just take this answer maxed out and L++, and then you keep on doing this, keep on doing this, keep on doing this, right till you can. And you will, of course, break somewhere where either the number was less than mx and your frequency was still 0. You were not able to gain back any more frequency. So, of course, this is a portion where you have to break. Because of this while loop, if you were trying to gain some frequency back, you are trying to make the window nice again, but it was not possible. Yeah, not linear. No, this is not linear two-pointer. Yes, Nazir, that's correct. Like we are trying to check every so Nazir, what we are trying to do is we are trying to check the lowest sized window such that it has at least one frequency of every number from 0 to mx minus 1. That is what our target is. Got it? My doubt was only to middle region. So that, okay. I hope. Okay, this is the doubt that you printed, but I think it's clear now. Yes? Okay. I think you're able to imagine this code now. Okay. Like overall, this is like, when you say linear in that manner, like in terms of time complexity, Pavan, this is linear. Yes. In that sense, this is linear. I thought linear means like you're running a for loop and you're incrementing only once. That is not the case. That way, this is not linear. Both pointers can run on different, you can say speed. Okay. I meant that way. Otherwise, this seems linear. Yes, that's correct. Because then you are only like this L pointer and this R pointer will only cover 2 times of the middle gap from the original L to R. Okay. Yes. Great. And then you print mx, mn and mx outside. Yes, that is the correct thing, right? I can write it over here. Anybody who's watching this video, I think if this while loop is not clear, we are trying to take the lowest sized gap here such that in that gap, all values from 0 to max minus 1 come at least once. This way, this gap can be treated as a middle portion and can be taken to form a possible answer. Clear? Dhruv, I hope this is clear with you also. Okay. So I think good problem. And then we simply print mn and mx. So I hope this is clear. Yes. Now, what is the time complexity? We are using sets and maps a lot. So I think n log n would be a good order to say. This is like an n order over here. This is like a log n order over here. Then you can say n order again over here. Then this, because of the set, this is like n log n again. I mean, you can optimize over here also by using unordered sets or unordered maps, but that's totally up to you. And almost everything over here is n order only. And then this is also roughly n order. And then this while loop is also roughly n order. And then this while loop is like 2 into n order, right? This is like n order inside this. And like you can say L also traverses n maximum and R also traverses n. So this is like 2 into n order roughly, which is like n order only. So we can say that overall, this becomes n order only, which is equal to O of 2 into 10 raised to 5. 2 into 10 raised to 5. Yes, that's correct. And what is the space? I'm using some extra space, of course. You can say O of n order maximum. Let's say everything is unique, then set and everything matches that. Okay, clear, guys? I think of an PCD. All right. Again, apologies for taking a PCD so late, but I think this helped. Let me stop this right here. Thank you so much, guys, for joining.